rushing in of the icy waters on the boilers. August Weichman.
I heard 4 distinct explosions, which we supposed were boilers. First-class passenger, Mrs. Stewart White.
As the investigators inspect the stern boilers, they can find no evidence of explosion.
The boilers from number 1 boiler room. It's a single-sided boiler. It seems in perfect condition. Therefore, it didn't explode or implode.
To be sure Titanic's other boilers didn't explode, investigators have to account for the ship's remaining units. Their search takes them to the bow section, where many of the boilers were housed. The decks here have collapsed, concealing a view inside the ship. But to the team's surprise, some wreckage has slipped away. For the first time, investigators can clearly see into one of the boiler rooms.
And what we found was all 5 boilers in place with no explosion damage. It gives us an indication that probably all 24 boilers that were in operation didn't explode and didn't leave their foundations.
If the boilers didn't blow Titanic apart, what could have caused it to break into pieces? Investigators now turn their attention to the steel itself. Could it have been flawed, contributing to the breakup? It's a highly contested theory. To settle the debate, the team needs physical evidence. An actual section of steel that broke free from Titanic. Investigators would like to cut a sample from a 20-ton section of hull dubbed the Big Piece. The piece is being raised as an historic artifact. But to the crash investigators, it's important for other reasons. The artifact came from the starboard side of Titanic, encompassing 2 upper decks of the break region. If it is weak, it could mean much of the steel here was also brittle. For retrieval, the artifact is connected to giant lift bags, which carry it 2.5 miles to the surface. Here, salvage teams work quickly to connect the piece to the recovery ship, a bay supporter. Suspended underwater, a piece of Titanic once again is touched by sunlight. As the crew works, they're careful not to cause any damage to this historic artifact.
Come on up. Bring it over to the side. Turn it around. Okay.
Despite their best efforts, it's difficult to control the massive weight in high winds. After several tense hours, a section of Titanic's hull is safely secured. David Livingstone and Bill Garsky now have a tangible link to Titanic's rupture.
Hey, look at this, right here.
We hope to learn much more about how the Titanic broke up. And perhaps make a better explanation why the vessel is in the state she's in today.
The gravity many feet in those days. I don't think it was.
Yeah.
Evac. Probably lead.
As the big piece makes its way to Boston for analysis, the expedition team monitors Hurricane Bonnie, which has stalled near the Atlantic seaboard. The hurricane is pushing bad weather their way. Nervousness underlies the proverbial calm before the storm. Many of the crew take advantage of the sunshine. It's hoped that rain and rough seas are all that hit the site, and that the hurricane never gets any closer. For now, it's a tense waiting game. The big piece arrives in Boston after a 4-day journey. In the harbor, materials scientist Tim Fakey meets with Titanic conservator Stefan Pennick.
On that side, you see a very flat edge over here, this region when we disassemble it. The big piece came from very close to the region in the stern where the big break occurred, where the ship broke up. So if we have a piece of the hull from right next to the breakup, it is entirely likely that that has steel that's very similar to the steel that was actually involved in the break. This part?
Can you put that on the light? The steel looks perfect.
Back in his lab, Fakey prepares a sample cross-section of the steel. Using what's called a fracture toughness test, he will measure its strength. This machine will subject the steel to forces in excess of 2,500 pounds. It's a slow bending process, similar to what Titanic went through the night of the disaster.
When the stern of the Titanic came clear of the water, the upper surface of the ship was loaded to several times its design strength. And how the materials react to this huge load is going to determine what happens to the ship. That's nice and tough.
As it turns out, Titanic's steel is surprisingly strong.
The steel shows toughness almost as good as modern steels and was actually quite adequate for the application of the Titanic. Okay, this is nice.
Fakey's work has helped to settle a debate that's raged for nearly a decade.
This is nice, tough material.
Investigators can now say with certainty that Titanic's steel was not flawed, and it did not contribute to the breakup of the ship. Next, investigators shift their focus to another potential cause: the powerful flooding of Titanic.